In this video, I want to talk about the Unified Modeling Language, or UML. As your software becomes more and more complex, you end up with hundreds and hundreds of lines of code. And we've seen lots of different ways of organizing that code. We've seen that you can use functions, you can use classes. Later on, coming up, we're going to see how we can use modules. We can organize things in a variety of ways, but we still end up with a lot of complexity, especially if you're talking to other developers that aren't working on the same project on a day-to-day basis as you are, or maybe they're working on the same project, but they're working in their own code area. And so communication becomes much more difficult. The more people you have, the more complexity the application is taking on. So over the years, people have come up with some ideas about what you can do about that. And one of those is the concept of coming up with a unified modeling language that would describe how your software is going to go together, typically concerning object-oriented programming or software. It doesn't have to be, but that is a common pattern. It usually follows alongside of that. Now, there's a bunch of different type of diagrams, and there is a committee out there that keeps looking at it. It's OMG, which is kind of a funny acronym, but they've been working on the the specification for a long time. Sometimes these different types of modeling diagrams come into favor and then eventually go out of favor. It's very fluid, and nobody seems to really follow the rules consistently. But there are three common ones that you'll probably see out there in the industry. And also, I think they're common just because they're kind of helpful and they're pretty easy to understand. But one of those is a class diagram. A class diagram allows you to go through and say, let's talk about designing a person class. What would that person class look like? What kind of data structures would be in there? What kind of fields and properties would be in there? Typically, you don't identify the fields and properties. You just identify the properties, and the fields are assumed. So I might have a property for first name, last name, date of birth, and I'd have a data type to indicate what type of data I'm storing. I'd have methods to go along with it, like I'd have the toString method or a getAge method. And I would list those out in my little diagram. This could easily be put on a whiteboard somewhere while you were talking to, 3-4 people on your team in the room. And as you can see, it's really easy to draw. Now, if we're going to make a customer class, we can indicate a customer class by making another rectangle, indicating what is unique about the customer class, such as customers have IDs, and the toString method would also be noted. And because customer inherits code from person, you use an arrow pointing back to the parent. Now, I've always thought this was kind of funny because you would think the arrow would go the other way. The code is flowing down into customer, but that's not the way it is. The arrow always points to the parent. Always. So, if you need a visual, think of a child walking along, reaching up to hold the parent's hand. The hand is pointing up towards the parent. The fact that there's two methods with the exact same name automatically indicates to people looking at your diagram on the board that the toString method is going to be overridden. And getAge is going to be something that is inherited along with first name, last name, and date of birth. So you can get a lot of information out of this one simple little picture without having to go through hundreds of lines of code or show them all the details about the attributes, the fields, the property procedures, or any of that. Which, let's face it, meetings are boring anyway. So, you want to get it done, you want to get back to work, the thing that you're actually wanting to do. Class diagrams can help with that. So this is a very handy tool. It's only one of the types of modeling diagrams. There's a couple other ones I want to point out. The next one's a use case diagram. Now, a use case diagram, you're going through and you're talking about how your software is going to be used. And there's an actor, and that actor is sometimes a human, a user, Sometimes it's a piece of software, and oddly enough, even if it's a piece of software, like another software uses the new software you're working with. Let's say that I don't know, a web page interacts with the data files that your application, your Python application makes. You would still use the little human symbol to indicate that software. I know it sounds weird, but an actor can either be a human or it could be some other application, another piece of software. Okay, and then what you do is you identify the types of things that can happen in a particular system. The system is the application. Now the system's a very philosophical container. It doesn't necessarily indicate which class things are in, which files they're in, which folders are in, or anything like that. It's just a boundary about what kind of behaviors or tasks can be performed within this system. Such as there's a task of being able to create a customer, or modify a customer, delete a customer, add a customer to a list, save the list to a file, get the list from a file. Those are all behaviors or activities that can happen in the system. And then you indicate which actors can interact with those particular behaviors. In our case, we're saying that the one user can interact with all those behaviors. But in other diagrams, you might see a situation where you have an actor, and this is going to look really bad. Oh, yeah. Yeah, that's pretty bad. Anyway, it was supposed to look like that. It looks kind of like it's running and pointing or something. But you could say that this actor only works with, working with the files only. And that could be another piece of software of some type. So that is called a use case diagram, and it's a very popular choice. And also, it's usually used in a meeting of some type, and you're putting it up on the board, and you're saying, hey, what if we build something that does this? And then you kind of talk about it before you even start coding. Or maybe you've already started coding, it's been about 3 weeks, and you come back and you say, this is what we started with, let's talk about if we need to change it. So, use case diagrams. If you get a job as a programmer, or if you're currently a programmer and you're just updating your skills to Python, then you've probably seen this. But if you're just getting started, and Python's often a very beginning language, you may actually see these in meetings once you start coding and getting more involved with the development of applications. A third one that is useful is composition diagrams. They go by a couple different names, but basically what their idea is that you identify how objects work together. So we've seen how we can make a customer object from a customer class, and then we can add it to like a list, like a Python list, as a collection of customer objects. This would be a form of composition. The list is created without any customers in it. It's really not all that useful. It's just an empty list. I probably should say that a customer list isn't useful unless I have at least one customer in there, but I've indicated that can either be that can either exist or it can't. You can have either 0 or 1. And if you do have one, you can have one or more customers. Now the n stands to the nth degree. So if you have one, you need at least one customer, and you can have as many as you want, as many as this thing can hold, to the nth degree. Aggregation is similar. If I have an employee and they have benefits, they have a relationship. With composition, it's a stronger link. A list without a customer list without a customer object is pretty useless as far as just an empty list. An employee without benefits, well, there's plenty of people that will argue that that's not a big deal at all. So we could say that the aggregation is a much looser binding. And as such, instead of it being mandatory, it's either 0 or 1. An employee either has them or they don't. If you have an employee, you either have one or you don't. And if you do, the relationship between that and benefits is loosely bound. That's what the empty diamond says. It's an aggregation. And you can either have benefits or not, 0 or 1. So with the composition diagram, you can describe the relationships between objects. Now, note this is objects, not classes. So when you make an employee object, yeah, it's from an employee class. Or customer object, it's from a customer class, benefits from a benefit class, and so on. Customer list is actually from the list class that's built into Python. But the deal is that these are objects made from classes. So composition talks about the objects itself and the relationships they have while they're up in memory. Remember, the class diagrams are used to identify the relationships between classes. So, guys, that's UML. And there's going to be a little bit of research in the homework this week to kind of look up and get a general idea about what's out there. I would not spend a lot of time on that yet. I'll talk a little bit about it when we get to the homework. So you don't need to worry about learning this in detail. But I would say that having the basic knowledge that these exist is useful. In fact, you might just kind of play with that a little bit and see if you could make some of these diagrams to identify what you have been doing in your projects earlier. But for now, that's it for UML. Next on the list, I want to talk about modules. So I will see you in that video.